Hey guys, this video is going to serve as another example of a worked calculation of calculating the average atomic mass. So just giving you another look at how to do that. So here's your problem. Naturally occurring chlorine consists of 75.77% of chlorine 35 atoms. The mass of those is 34.97 AMUs. And 24.23% of chlorine 37 atoms, and the mass of those is 36.97. So go ahead and pause the video and see if you can calculate the average atomic mass for chlorine. All right, so first things first, we want to organize our thoughts or organize the materials. The way that I had it on the other lecture and the way that I decided to do it this way as well is to set up sort of a table. So here we've got our two isotopes, so chlorine 35, chlorine 37, and then I respectively wrote down their masses. So chlorine 35 had a mass of 34.97. Chlorine 37 had a mass of 36.97. So just gave them their atomic masses. And then next to them, I also wrote their natural abundances. So just putting the material in an organized fashion so that we can do math. Okay. So to calculate this, we are going to take the mass of the particular isotope. We're going to multiply it by its natural abundance. And remember, this gets moved over the decimal 2 places. So we're going to multiply by decimals. So let me plug that into my calculator. The other thing I'd like to look at here before I start diving too deep into numbers is all of these strategically have 4 significant figures. So as I'm starting to report my calculation or my multiplication numbers, I'm going to adhere to those 4 significant digits. So first I type in 34.97 times 0.7577. And that's going to give me 26.49. And now I'm going to do the same thing for the next one. So 36.97 times 0.2423. And that's going to give me 8.957. Okay. Now we're just going to simply add these two numbers together. Addition and subtraction, we're going into a different set of sig fig rules. So here we're counting decimal places. So my first number has 2 decimal places. My red on red, that doesn't look good. My first one has 2 decimal places. The second one has 3, so we're going to have to cut it off after the second decimal place. All right, so let me add those two numbers together. 26.49 plus 8.957 equals, and the answer is 35.45. That would be the number I'd report, and the unit is AMU. If you guys go to your cheat sheet, your periodic table, you could look at the average atomic mass for chlorine. And the periodic table that I'm looking at has an average atomic mass of 35.453. I don't know that we could get much closer than that. I hope you guys found this example helpful.